Let me start recording, this time with sound for your classmate who's not here. Alright, so find the equation of a line that contains the points, and I'm given 2 points, 7, negative 8, and negative 7, negative 8. Alright, so I've written down the 2 points. If I look at my Unit 2 review sheet, and look under point slope form, I see it's useful when given 2 points. Why? Because I can use the 2 points to find the slope. So let's go ahead and find the slope of this line. This is going to be my first point. This is going to be my second point. So y2, negative 8, minus negative 8. X2, negative 7, minus 7. So distribute this negative, we get negative 8 plus 8 over negative 7 minus 7 is negative 14. Negative 8 plus 8 equals 0 over negative 14. This means we have a slope of 0, right? So we actually don't need to go any further than this. Because remember, we talked on it briefly, kind of when we went over parallel and perpendicular lines. When we have a slope of 0, the equation is a horizontal line, right? Here, we have a slope of 0. That means we're going to have a horizontal line. And we can see that in our behavior of our 2 points. They have matching y values, right? Different x's, matching y's. So since they have matching y values, we can just say that the equation of the line is y equals negative 8. If we utilize this, we have, this is the origin, 0, 0. This is negative 8. This is 7, negative 7. We have our 2 points. So since our slope is 0, we know we have a horizontal line. That line is going to be equal to the y values of our points. So y equals negative 8. Going back to our problem, we see that's an option. Y equals negative 8. We can use Desmos to graph it. Y equals negative 8. And we can even see that at 7 it equals negative 8. At negative 7 it equals negative 8. So our answer to this problem, where our y values in each point were the same, is y equals negative 8, which is the horizontal line that we see here. Alright, now we're given a word problem. Andre steps into an elevator. What do we know about elevators? They go straight up and straight down, right? This is Charlie in the Chocolate Factory. Elevators go straight up and straight down. So if we draw this, we can draw an elevator. He gets on the 7th floor, pushes the button to go to the ground, so he's going down. And then if we plot this on a graph, we should get something like this. We have the elevator going straight down. This is indicative of a vertical line, right? We're going straight up and down because that's all elevators can do. We're going in a vertical line. Now, if we look, so now we kind of get how the elevator is moving and what it relates to. Let's look at our questions. We're asked to find the slope of the elevator. Well, what do we know about vertical lines? From our Unit 2 review sheet, a vertical line, the slope is undefined, right? Because you get your change in y over your change in x. You have a change in y. We're not changing x. We're going straight up and down. So whenever you divide by 0, you get an undefined value. So our slope for a vertical line is, yes ma'am? Okay, if you need to go get it. So, looking back at our question, we're asked the slope of the elevator movement. We just determined that the slope is undefined, right? Because it's a vertical line. So that's going to be our answer. If it was one of those escalators you see at an airport that really lazy people take, that would be a slope of 0, right? Because there's no change in y, but there's a change in x. And we know it's not positive or negative because it's not going up or down at an angle. It's going straight up and straight down. All right, so question number 8. We're given 2 points. Let me write those down real quick. All right, and then we're asked to find the equation of a line that contains these points. So I'm given 2 points. I need to find the first thing, whenever I'm given 2 points, I should try to find the slope. Now, if we also kind of look from a previous problem, we see that our x values are the same. Let's just make a note of that. Let's go ahead and plug these into our slope formula. So y2 is 2 minus negative 2 over 3 minus 3. All right? So we get 2 plus 2 over 0. We get 4 over 0. What did we just talk about? This is an undefined value, right? So our m value is undefined. Because you can't divide by 0. At least in algebra 2, you cannot divide by 0. When we have an undefined slope, we know the equation is a vertical line. Vertical line equations are x equals equations. Now what do we get for our value? Well, if we look at our points, our x values are the same. So our vertical line equation is just going to be x equals 3. So this means for every value of y, x is going to equal 3. To go back here, we type x equals 3, equals 3. We get our line, our vertical line. Notice the slope's undefined because there's no change in x. So we have a 0 change in x, undefined value. We get on here, we have the choice, x equals 3. Again, we got that by plugging our points into our slope formula, and we got our undefined value. And from our cheat sheet, or review sheet, whatever you want to call it, we know that when m is undefined, the equation is a vertical line. Vertical lines are x equals equations. X equals what? The x value of both points. Notice that these are the same. So if you sit there and say, oh, the x values are the same, I know I'm going to have to get an x equals equation. Write the slope still, because that's actually how you prove you know you have a vertical line. Because you prove that the slope is undefined. So we get x equals 3 for this one. All right. Number 9, we're given a point. Then we're given a slope. Whenever I'm given a point and a slope, what equation should I be thinking about? Clearly in the name. So if I'm given a point and a slope, anybody? Exactly. And then I also, what I was kind of talking about before lunch, I notice my answers are in standard form. So I'm not going to waste time putting it in slope-intercept form or some other kind of form, because I want standard form because that's where my answers are. So knowing that, and knowing that we have to use our point-slope formula, which is y minus y1 equals m distributed to x minus x1. We have our slope, and we have our point. x1, y1. Y minus negative 2 equals negative 2/3 x minus 1. I just plugged in the information that was given to me. Distribute the negative. Y plus 2 equals, distribute the negative 2/3 x plus 2/3. Alright. Now I need, I'm writing it in standard form, right? So standard form is ax plus by equals c. So I need all my variables on one side, all my constants on the other. So I'm going to add my 2/3 x over. And then I'm going to subtract my 2. But I have a fraction over here. So I really want to subtract 6 over 3, right? Because I need a common denominator to subtract. 6 divided by 3 equals 2. Everybody get that? Cool. So I get 2/3 x plus y equals 2/3 minus 6/3 is negative 4/3. So I'm here now. So looking at my answers, I don't have fractions. So what I need to do is I need to eliminate the fractions that I have in my standard form right now. So to do that, luckily I have the same fraction on each side, or same denominator. I can multiply both sides because I have an equation here. So as long as I do the same thing to both sides, it's all valid. So now I need to distribute this 3. Well, 2/3 and 3, the 3 cancels, so I have 2x. I need to distribute the 3 to the y, plus 3y, negative 4/3 times 3. The 3's cancel, I'm left with negative 4. That's more in the form that my answers are, right? So I look over, I get 2x plus 3y equals negative 4. Any questions on that one? I have a point and a slope, so I know I'm using point-slope formula. I also analyzed my answers and knew I need my answer in standard form. The reason I did that is I don't want right here, all of a sudden I put it in slope-intercept form, and then I got to convert back. So I don't want to do extra work. So I figure out what my answer is supposed to look like, then I set it up that way. All my variables on one side, all my constants on the other. All right, and then the final question. We just asked to find the slope between two lines. You all know how to do that, right? Our slope formula, change in y over change in x, which equals rise over run, which equals y2 minus y1 over x2 minus x1. So I'm going to denote this as my first point, this as my second point, and then I'm just going to plug them into the equation. y2, negative 2, minus y1, 4, over x2, 3, minus x1, 2. I get negative 6 over 1. That reduces to negative 6. That is my m value. Any questions on that? That's just using our slope formula. Change in y over change in x. Doesn't matter which point I label as my first or second. No, it does not. As long as I'm consistent. So if I labeled this as 2, then I would have to put 4, 2. I just have to be consistent to where I'm plugging them into the formula. Either way, I would have got negative 6. We can confirm that real quick. Negative 2 over 2 minus 3. We get, this is plus 2, so we get 6 over negative 1. Reduces to negative 6. They match. Does not matter which point I use as long as they're consistent. Alright, so that was the quiz that you took yesterday.